Good evening, friends. Welcome to 360DigiTMG. Today we are going to discuss about chain of thought. Chain of thought with self-consistency. So, this technique involves to improve correctness, like how we can improve a model in like our large language model. Okay, so there are different challenges that our model face. Okay, like local optimality and statistically during the text generation. Okay, so what is the procedure to do this chain of thought? So we will ask a model to iteratively think like a step-by-step approach it should follow, and then it will give us the answer. Okay, so for that we have what are the different advantages? Okay, so advantage of this chain of thought is improved performance. If we are using this for suppose mathematical calculations and other things, so it will think wisely. It will think the calculation, what was the first calculation. It will think by the second calculation, third calculation, fourth calculation, and then after that, it will give you the summary or the output. Okay, so it is based on the improved performance. Then there is demonstrated boost on the benchmarks. Like if earlier we are getting 3.9% of improvement, by using this, we'll have the improvements over more than 3.9 to 17.9% improvement can be seen. Okay. Then there is enhanced reasoning. Okay, it will follow a reasoning steps. Like if there is an apple, how many apples, if two people eats two apples, so how many apples are remaining? If the total apples are 10. So it will think likewise, and then it will tell us that the total apple remaining will be 8. Okay, it will follow a step-by-step approach and then give us the output. Then there is comprehensive understanding through multiple perspectives. Okay, so these are the things. Then there is chain of thought prompting. Like what is the benefits of doing this? So as we have already know what it will do, it will have a improved accuracy. Okay, by explicitly outlining the reasoning steps, like first step will be this, second step will be this, third step will be this, fourth step will be this. Likewise, it will lead to more accurate and reliable results. Okay, especially when it comes to complex tasks with multi-step logics, like a mathematical task or something like that. Okay, it will have enhanced explainability. The transparent chain of thoughts will make the LLM reasoning more understandable, allowing for debugging. Okay, debugging analysis and improve trust in its output. Then there is tackling the complex task. Like chain of thought will empowers LLM to handle problems which will have multi-step reasoning, or it will have some logic behind. Okay, what is the logic for this? Okay, so when it comes to reasoning, logic, or some types of mathematics is there. Okay, application of knowledge or something like that. When it comes to complex task, we can use chain of thought. Okay, then there is adaptability to diverse domains. The techniques can be applied to various tasks and domains. For scientific reasoning to creative writing, where understanding the reasoning process is crucial. Okay, now what are the different challenges when it comes to chain of thought? So chain of thought currently requires large LLMs, like 100 billion parameter for optimal performance. Means it requires large parameters to train the model, and then we can expect the model will give us the optimal performance. Then crafting the effective few short examples by challenging. Then research is still going on to improve the scalability and generalizability of chain of thought prompting. Okay, so the purpose of chain of thought or the chain of density. Now there comes chain of density prompting. Okay, what is chain of density prompting is? The purpose of chain of density is to enhance the summarization performance of a large language models, just as that of GPT-4. Its main goal is to regularize how much information is included in the resulting summary. Okay, it will understand it and understand the complicated information, and it will make into some balanced explanation. Okay, means it will do, for example, if we are using the big for where there is very long sequence of data and we want to summarize that data, we can use this chain of density prompting. Okay, when there is very complicated information present, we can make that into a well-balanced explanation, which is what chain of density seeks to do. The AI model is guided by unique prompts to incorporate crucial data while excluding the superficial one. Okay. Then, what are the steps of chain of density prompting? So, first step is to determine which text should be summarized. Which text we can summarize. Okay. Choose any text that you want to summarize, whether it is an article, a document, or a PDF file, and so on and so forth. And what we will do, the next step will be formulate the first prompt. Like, formulate the first summary question based on the chosen material. Whatever the chosen material we have taken, like we have taken an article or document or a PDF file or a Word file, whatever. Okay, whatever the document we have taken, we have to take that and we want to make into one summary. Okay, so the first summary question will be based on the chosen material. So here the goal is to direct the large language models such as GPT-4 in a direction of producing a fundamental synopsis. Okay. Then the third thing here will be examine the first summary. Okay, what was the first summary question? And according to that, we will examine the first summary from there. Okay, so the synopsis that the first prompt produced will determine that the summary is extensively rich or too sparse, or missing important information is there. Okay. If it is very good, if it is extensively rich, we can use this, or if it is missing some information or missing some details, we can create another chain prompt. Likewise, okay. So create the chain prompt, create more prompts to modify the summary's amount of information. Okay, like if it is missing, the most important information only it is missing. From the original data, it is missing the most important information. So what we can do? We can again tell our model to do this. We can again add a prompt, create a chain prompt for this. So the chain prompts form the foundation of the chain of density methods. Then there is implement link prompts, which refeed the LLMs with these chains instructions. These prompts are intended to either add more important facts and raise the density, or it can subtract the unnecessary information or lower density values. Okay, what it will do, either it will add some information or it will remove some of the information from the given article or whatever the document is. Okay, if some part which is irrelevant or which is not required, we can lower that low density or we can subtract that lower density things. Okay, then we will again examine the modified synopsis. Okay, then check out the updated summary that results from the running the sequence prompt again. Okay, the sequence prompt which we have run earlier, again we will run that sequence prompt with some updated summary. Okay, make sure it includes everything important and leaves out anything extraneous information. Okay, and likewise we will repeat this thing as in fourth. Okay, so repeat as needed. Go back to step number 4 and modify the required or modify the chain questions if the summary still doesn't satisfy the required information. Okay, or a density standards. So as in fourth, we will get the best summary from this article or whatever the information which are relevant to this, we will go and do the same task. Then if we will have the complete the summary, so the summary is deemed completed and usable whenever it reaches the appropriate information density. Okay. So this is what a chain of density prompting is. After that, we have tree of thoughts. Okay. So tree of thoughts will do what? It will emerge from the fertile grounds of prompt engineering. Tree of thought blooms as a powerful techniques for guiding large language models, like through a very complex problem solving landscapes. Unlike its linear cousins, chain of thoughts or a chain of thought, tree of thought embraces intricate branches of possibilities also. Means what are the possibilities? Here we have understood about the input-output prompting. Here we have understood about means zero-shot prompting. One prompt we have given, the output will be get. Okay. Then we have understood about the chain of thought. Think step by step and analyze the concept and then give us the output. This is what a chain of thought is. Then we have understood about the self-consistency or a chain of thought. Okay, so it will take the most important features from here and only that will be taken. Majority of the votes, which is having more majority of the votes, we will take that part and skip the other, which is having lesser parts. Okay, likewise, there is tree of thoughts also. Okay, so it will have some branches. From this particular branches, which is important if this is a sequence, what is important for here? What is important from here? What is important? So it will form one tree diagram. Okay, from this tree diagram, like a tree of thoughts. If this has happened from this, what are the different scenarios can happen? Likewise. Okay, so how this tree of thought works? So, firstly, what it does. We will understand first what it does. So tree of thought blooms as a powerful techniques for guiding our large language models through a very complex solving landscapes. Unlike its linear cousin tree, a chain of thoughts, tree of thought embraces the intricate branches of possibilities, mimicking like a human thought. Okay, how the human will think if the particular situation happens. Okay, so what you are going to do, what are the different scenarios can happen. Okay, if this has happened, this has happened, this has happened, this has happened, like what are the different scenarios or what are the different projections that can happen for this outcome or this input. Okay, so according to that we will generate what will be the different outcomes from here. Okay, so how this tree of thought will work? So it will work on the program decomposition. It is similar to that of chain of thought only, but the tree of thought will start by deselecting the intricate problems into smaller, or what we can say, more manageable substeps. Okay, so it will start and deselecting the what are the things which is not that important. If it is not that important, we can skip this. Think about these two parts. Now from these two, what is important? So there are 4 or 5 things which are important. From here, which are the things which are most important? So we'll take that only and skip the rest of the parts. Likewise, we will form one tree types of, and according to that, we will form one outcome. Okay, so it will deselect the intricate problems into smaller and more manageable substeps. Think of it as a laying the groundwork for a tree to sprout. Okay, like branching possibilities. Like what are the different branching possibilities it can do? At each substep, chain of thought doesn't limit itself to a single solution. Means for here, it is not following only single solutions. Like for here also, we can have multiple solutions for this. This is a situation, this is one projection, this is one input. For this, how many projections are there? So there are 3 projections for this input. Now, based on this 3, we are selecting only 2 projections. One we have skipped. Now, based on this 2, how many projections, how many chances are there? Like this situation, from this, what will happen? So we'll take that. Okay, we'll take that information which are more relevant. Okay, so completely it will think all the things, and from there it will give more importance to the features which is having more importance or are likely happening. which is more likely to happen, it will give you more score for that. Likewise. Okay. At each substeps, tree of thought doesn't limit itself to a single solutions. It generates multiple candidate answers, which will forming the nascent branches of trees. Okay. Each branch embodies a different approach of tackling the sub-problems. Okay. If this is a problem, what are the different problems can arise from this problem? Likewise. Okay. Then it will follow an exploratory reasoning. The LLM will dive into each branch, generating the intermediate thoughts and evaluations at every turn. This will resembles a mini brainstorming sessions. Okay, now this is the thing, this is the thing, this is the thing. What are the thing? What is the more possibility, or what is the more probability that this will happen after this? Likewise, so it will resembles a mini brainstorming sessions within each branch itself, and discarding the ideas that leads, which is not that important, and nourishing the promising avenues. Okay, only we are taking the parts which are having more probability of happening. Okay, convergence and refinements. Then, as an LLM will explore these multiple paths, it gathers insight and evidence. Eventually, it converges on the most promising branches, refining and converging them towards a final solution. Okay. So now there comes an XOT, which is called as everything of thoughts. Everything of thought is a cutting-edge prompting techniques that's shaking up the world of large language model. It leveraged the combined power of reinforcement learning and Monte Carlo research to inject the external knowledge and guide the LLMs towards superior reasoning, performance, and efficiency. Here's how XOT, that is everything of thought, works. Okay, it will take Monte Carlo research module. Okay, MCTS module, which is a Monte Carlo tree search module. It will imagine a manicure. Okay, explorers in navigating a maze. Okay, it will have everything of thought in this MCTS module, which will act like an explorer, which will use a lightweight policy and value the networks to efficiently more potential thoughts, or having more thoughts which are having more important thought, we can say. Okay, a thought structure for a given task through a simulations. It's like brainstorming on steroids. Okay, consider this as a brainstorming on a steroids, or a rapidly identifying the promising avenues for the LLMs to pursue. Okay, then there is LLM solver. So think of the LLM as highly knowledgeable but directionless scholars. Okay, it is highly knowledgeable in various, yes, it is. It is highly knowledgeable in varieties of millions of parameters. Okay, but it is directionless. We have to give the prompt accordingly to get the desired output from there. So XOT's LLM solvers takes the MCTS, that is Monte Carlo's tree search generated thoughts, okay, and it will structures and refines them using the LLM's vast internal knowledge base. Okay, it polished the rough diamonds discovered by the MCTS module, which is a Monte Carlo research modules, ensuring that the solutions are not only creative but also grounded in the factual accuracies and logical coherence. Then there is collaborative reasoning or collaborative revision. So this is where the magic happens. Okay, everything of thought fosters a back and forth exchange between the Monte Carlo research module and the LLM solver. The Monte Carlo tree search module continuously refines its explorations based on LLM's feedback. Okay, now what has the prompt, what we have given as a prompt? Okay, based on that prompt, what is the output coming? Okay, so what the other query will raise, what will be the other prompt? Okay, while the LLM solvers will keep improving its solution. Okay, the LLM solver will do what? It will continuously improve its solution based on the Monte Carlo research modules, discoveries. Okay, so this dynamic interplay leads to ever better results, often surpassing what either components could achieve alone. Okay, then there is chain of thought is a cutting. What is about the chain? What is about the everything of the thoughts? Okay, so everything of thought, that is XOT, is a cutting edge prompting techniques that's shaking up the world of all. Okay, so as we have already seen, there is MCTS, there is LLM solver, there is collaborative reasoning likewise. Okay, so this is it, guys. So we'll understand these things. Okay, first we have understood about what is chain of thought. Chain of thought means it has already trained some 100 billions of parameters, but we have to give them the direction. Okay, so we will put one, it will generally useful for complex tasks. Complex task means mathematical operations or where there is certain reasoning or logic is required. Okay, then we have understood about chain of density prompting, which is generally useful for what? Generally useful for summarization. Okay, if there is very long sequence of data and we want to summarize that, we can use this chain of density prompting. Then there is tree of thoughts. So tree of thoughts will do what? It will take all the possibilities can happen for this particular input. What are the different possibilities that can happen? And within this, what are the other sub possibilities that can happen? What are the different other sub branches? Okay, so it will have all the branches and their sub branches. And from there, we will take the most important thing and skip the things which are not that important. Likewise, we will get some of the output from here. Okay, so this is what a tree of thoughts is. Then we have understood about everything of the thoughts, wherein we are using a Monte Carlo tree search, which is an external knowledge base. Okay, so this is it, guys. I hope this is understood. We'll meet you with the next lecture. Okay, thank you for joining. Meet you on next Saturday, 5 p.m. Thank you for joining. Bye-bye.